Boom. Hey, good afternoon, everyone. Wonderful Saturday today. Today, I'm going to be bringing you guys a wonderful Saturday edition of some useful cannabis knowledge with respect to neuroplasticity or flexibility in our nerve connections and how they go about communicating with one another. So cool. Listen, guys, welcome once again. I'm Dr. Dan. I run Ozark MMJ cards and I run the channel here. And I, from time to time, upload these YouTube videos that hopefully some will find useful. So, boom, let's kick it right off. So, neuroplasticity, big word. Okay, but let me just simplify it because I think that's the most useful direction to go when we look at some of these scientific terms, medical terms, what have you. Basically, neuro meaning nerve and plasticity meaning plastic, the ability to remain dynamic, and if I can use the word malleable, which is a term that we use to say if something that's usually sort of stiff and hardened, we can make it more flexible so that it can be formed into a different shape or form. So really, when we're talking about neuroplasticity, we're talking about the ability of the central nervous system, and we'll say the peripheral nervous system too, outside of the brain and spinal cord. Central being in the brain and spinal cord. The ability of those nerve and the nerve connections, those synapses, to grow and change as we adapt to a changing environment, as we grow older. Okay, the things that we're going to learn are going to change as we grow older and become more mature. And the interesting part about neuroplasticity is maybe just 50 years ago, the prevailing thinking was that our nerve networks would grow and continue to change into, I guess, adolescence and puberty. And by the time we hit adulthood, between 18-22, something like that, the nerve connections are pretty much set permanently from that point on. That was the thinking then. Okay. We know that now to be completely untrue. Many nerve connections can be set in the formative years and might remain so throughout life. But the great majority of nerve connections that we have, we can clip and remove and add and change. And these things remain changeable, mutable throughout our entire lives, all the way into old age. Okay. So the flexibility of our nerve connections, that adaptability, that continues throughout life. Okay, throughout life, all throughout our entire lives. Of course, as we age, the the plasticity of our nerves and the ability of our nerves to be more and more adaptable, that decreases as we age. We do retain some ability to do it as we age, but overall the ability of it, that does decrease over time. But we can mitigate this decline in nerve flexibility through engagement of the endocannabinoid system. Okay. I know the prevailing message maybe 40 years ago was that, in using cannabis products, this can damage your brain. This can lead to permanent brain damage or predispose you to some kind of neuro- neurological dysfunction later on in life. Okay. And we found that really from all information that we can access now, we found that not to be the case. Okay. And the reason why we can say that is from peer reviewed literature that does indicate that uh, cannabis products and engaging the endocannabinoid system is actually neuroprotective. Okay. It actually reduces the amount of inflammation surrounding the nerves, so that if the nerve remains in an uninflamed state, it can probably function a lot better and be at its most efficient and optimal operation. Okay, so that's when we engage the endocannabinoid system. And we can probably infer that the reason why that's the case is the whole scope of the endocannabinoid system is to bring about homeostasis in whatever organ system that it's operating in. And we found the endocannabinoid system to operate in basically every organ system in the body. Okay. So that's the reason why when we're talking about neuroplasticity, what we're talking about is the ability of the engagement of the endocannabinoid system to keep the nerves functioning at their most optimal performance, where they're getting optimal delivery of nutrients, okay, and the most effective cycling of waste products out of the nerve cell, and also maintaining the synapses where the nerves talk to each other, where one nerve terminal is talking to another nerve terminal through the neurotransmitters. What happens is in plasticity, those nerve connections that we're going to need the most at that phase in our development or adaptive development, those nerves that we need the most and are going to benefit the most from in that environment, we're going to maintain those the most, so that we have a maximal number of neurotransmitter receptors and neurotransmitter substances being shuttled in between neighboring nerve cells. Okay. Conversely, those nerve highways that are no longer useful to us at a particular stage in our development, for example, maybe in our formative years, we would have had some frontal lobe, the learning executive part of our brain. We might have had some frontal lobe zip code dedicated to learning how to tie a shoelace, and the discrete steps involved in that, making a little loop, tying it around, pushing it through, pulling it through, and getting it tight without getting all frustrated. I remember it frustrated the crap out of me until my dad taught me how.